So, folks, maybe we'll get started and maybe folks will join on. So, today's session will be a very introductory session for AI, ML, and data structure. So, I'll try to cover very basics. We'll try to give you like abstract level understanding of what these terms means and how you can basically uh, go forward for learning more things about these terms. So let's get started. So by the way, I'm Nirav, and so I'll be your instructor today for this session. And so I'm working with Microsoft in business applications platform, and I'm very passionate about teaching as well as helping others. So, and one of the things I always believe in my life is uh, one success always depends on the platform one can achieve. So, this is one of the quote which I like. And today's session will also be maybe a bit flavor of this, where I'll try to give you information related to what these terms mean and how you can leverage this term and the basic understanding and basically build on top of that and achieve more. Okay. So, so this is the outline of the session. So first we'll start with the value proposition of this, the AI and ML. I think many people will have heard these terms, and then we'll go into bit details of what these terms mean and what are the different parts of this technology. For example, artificial intelligence, what is machine learning, what is data science, and then nowadays there is a new word coming up which is called deep learning. And finally, we'll see what are the relationship between all these terms, like because these are very similar sounding words, and there is a lot of confusion in the community about what exactly it means and where one like what is the boundary of one particular area and another starts. So I think then we'll see what is the relationship between these terms, and finally we'll see what are the challenges in this field, and we'll conclude the session after that. Okay, and throughout the session, if you have any doubt, please stop me and please ask if you have any doubt. So the value proposition of this field is, so if you know the McKinsey group, which is one of the biggest group in the world, they have done one survey on this field where AI is estimated to create 13 trillion US dollar worth of revenue by year 2030. And as the AI and the data science and other machine learning, this field grows, all the fields, like starting from medical science to commerce to e-commerce or any computer science field, everything is going to be affected by this field, AI. So definitely there is a lot of opportunities which are coming, and especially in the developing countries like India, China, they have tremendous amount of opportunity. So definitely this is a very interesting field if you want to build career. And I think nowadays there are a lot of new jobs which are opening up for this field, and definitely to learn this new concepts might help you to get very nice opportunities. For example, if you take any big companies today, like Google, Microsoft, maybe Nvidia in the graphic side, Amazon, IBM, Baidu, which is one of the like biggest player in the China market, Facebook. So I think all these companies, they are now like shifting their focus to the AI related stuff. They are doing the normal stuff which they were doing earlier. For example, Microsoft. I work at Microsoft, so I can talk more about Microsoft. So Microsoft has been in the market since 1980s, but recently Microsoft has shifted the focus to the AI and cloud side. So that also indicates that there is like inevitable force which is coming in the market, where if even the companies like Microsoft, Google, if they are not able to capture the AI related stuff, then I don't think these companies will be able to move forward and sustain their position in the market. So I think it's a humongous opportunity for students like you and anyone in the market. Like you, definitely there will be a very new kind of jobs which will come up in the next upcoming decade. Uh, so I think it's very good to learn about this, and uh, I'll try to give my best to basically make sure that you are aware of these terms and how you can leverage this. Uh, so uh, Before we begin, so I will try to basically give the reference or credit to the one of the folk. This is the picture you see. It is from one of the course which is called AI for Everyone. So this guy Andrew Ng, he's the co-founder of Coursera. I think many of you might have used the Coursera, and he was the person who led the Google Brain project, and he's one of the like biggest scientists in the research community, and he's also a professor at Stanford University. So what I have done today is recently is one of the course came out which is called AI for Everyone, and this is a very nice course for any like even non-technical people also if they want to learn about AI. So what I have done is I have taken many of the content from this course and also included my understanding and my knowledge and kind of try to give you the best content out of it. So, so that was the credit, and now let's begin. So first we'll start with artificial intelligence. So the session I have structured in the manner where first I will talk about separate terms, like for example, what is artificial intelligence, what is machine learning, what is data science, and then finally at the end we'll see how they are related to each other and how basically they interact with each other. So let's get started with the term AI. So AI, so if you simply break in the English, is artificial, second is the intelligence, and which combines into artificial intelligence. So artificial is nothing but say it's like made by people. Often we are copying something from the natural world. That is called artificial, and the intelligence is nothing but if you term it in a very simple words, then it's the ability to learn and solve problems. And finally, if you combine this, then it will be like the result will be artificial intelligence, which is nothing but it's a simulation of human intelligence by machine. That means you are creating some machine or software which has ability to solve problems and learn by itself. Now, these all terms are very generic terms. So, and behind this also there is a lot of philosophy where some scientists try to analyze what intelligence is, what consciousness is. For example, if you ask yourself, what is intelligence? What is intelligence? What does intelligence mean to you? What does consciousness mean to you? So that kind of question also asked, and there is a philosophical aspect of AI also, but we will not go into the philosophical aspect. We'll mainly revolve around the technical aspect of AI. So this is very simple definition. So artificial intelligence, means to summarize it, it will be a machine which can solve problems or learn by itself, or sometimes act like human. Okay, so I think definition is simple. So let's go forward. So artificial intelligence has been around in the world since 1950s, and there are two broad categories of artificial intelligence which people are basically categorized into. People have categorized into. So one is artificial narrow intelligence, and second is artificial general intelligence. So narrow means it's obviously a small set of intelligence. So, for example, a smart speaker or self-driving cars or facial recognition. So, narrow means it's very specific to particular task. So you can call this artificial narrow intelligence to be very specific to particular task. And there is another term called artificial general intelligence. So general intelligence in the sense, so if you guys, obviously you guys see the movie, but if you have seen the Terminator or Matrix, those kind of movies, in those movies there are humanoids or human robots which basically act like human, and they have the ability to almost like they are indistinguishable from the humans, like they are almost human and they can do whatever a human can do. But so if we see today's world, maybe 2019, then almost like 100% of the work which has been done till now, it's almost related to artificial narrow intelligence. So this very simple example, for example, a smart speaker. You guys might have heard about Alexa or Google, Google and everything. Like there are many, Cortana from Microsoft, and self-driving cars. Nowadays, Google is building, Uber is building self-driving cars, facial recognition. Whenever you upload a picture on Facebook, then Facebook automatically recognizes the persons in your picture. So they are very specific tasks. They are not very generic. For example, if you give maybe self-driving car task to a Facebook facial recognition software, then it won't be able to do it because the artificial general intelligence is not there, and many people believe that it may take 100 years or maybe 1,000 years to reach to this level. So I think there are many people in the media, they are scared that in the near future humanoids or robots will take over the world. I don't mean personally, I don't believe that is going to happen soon, but definitely there is a tremendous amount of scope in the artificial narrow intelligence, and I think today we are going to focus on that. In this slide, what I have tried to cover is the very brief history of artificial intelligence. So let's start with the 1950s. So if you have heard about the father of computer, Alan Turing. So he first gave one of the tests, which is called Turing test, which is one of the most famous tests in the artificial intelligence community. So 1950, he gave a test called Turing test. So let's see what is this Turing test. It's very simple. Just a second. I'll start my whiteboard. So suppose that so this test is about testing the ability of computer or software to converge like human. For example, so in this particular test, there will be two rooms. So this is first room. This is the second room. Now in the first room, there will be either computer or a human. Okay. And in the second room, there will be experts sitting there. Now, what this test is about is the human or computer, we don't know. So this is a kind of black box. The expert, they don't know who is sitting in the next room. Now, experts will try to communicate with the human or computer. They are not aware whether the person sitting in the next room is a human or some computer is talking to them. So now they'll try to communicate with the next room computer or human, and computer or human will respond. For example, if it's a human, he will say, if these guys experts are saying hi, then maybe the human will reply, okay, hi, how are you? Or maybe if there is a computer, then it will reply based on whatever the software or the program has been written. So now the test is, if experts, say for example, there are 3 experts. So if they will try to communicate with the next room, and they will evaluate whether the person sitting in the next room or the computer, whether basically if they are able to identify that the person or the computer correctly, then that means that the computer has failed the Turing test. And if experts are not able to identify who is talking, whether it's a computer or it's a human, then the Turing test has been passed. So this is a very simple test, and it's very famous. So till now, there is in community, it's like always debate about this test, and people think that nobody has cleared the Turing test till now. There are some results which are very interesting and significant, but people believe that nobody has passed the Turing test. So this was about the Turing test. So it was in 1950, and 1955, first time the AI word came out. So John McCarthy is one of the well-known scientists in the AI community. He gave this term artificial intelligence. And since then there has been a lot of research, and so I am skipping some of the parts, so I'll talk about some of the relevant parts. So in the 1966, there was a robot called Sheki, and this was one of the robots which worked on the something called robotic planning. So it's kind of sub part of the AI, and it was very significant idea about how you can plan the things. For example, if robot is sitting in one room and you ask the robot to pick up one of the packets from one corner of the room and drop it to another corner of the room, then how the robot will plan everything. So it was related to that. So and after that, in 1997, there was a huge breakthrough, which is in the game playing history of artificial intelligence. It has been like one of the significant milestones, where a computer called Deep Blue from IBM, it defeated the chess champion Garry Kasparov. So Garry Kasparov was the grandmaster, and he was like one of the best players in the world. And in 1997, first time the Deep Blue computer beat the Garry Kasparov in the tournament of chess. And after that, there has been exponential research happening in the AI field, and I think many of you now are aware that Siri or Alexa or Google Assistant, I think there are a lot of virtual assistant technology which has come into market. If you guys know about IBM Watson, which is also like a very nice and sophisticated machine which can answer your question. And finally, in the 2017, recently.
Sorry to interrupt you. Maybe you would like to switch to your presentation back.
Okay, still you are not able to see the presentation?
Yeah.
Okay, sorry. Okay, can you see now?
Not yet.
Okay. Now, can you see?
Yeah, it's visible now.
Okay.
Yeah, thank you.
So, folks, please interrupt me if because I can see my screen, but maybe the online folks cannot see the screen. So please interrupt me if you are not able to follow what I'm speaking. Sorry for the glitch. So now we'll move forward actually. So now there are a lot of AI terminologies which are there in the market. So first we talked about artificial intelligence. In future, we'll talk about machine learning, data science, deep learning. And there are other few terms which we are not going to cover, which are out of scope for the session, which is like one of the terms in the AI search, knowledge representation and reasoning, game search, robotic planning. But when I talk about the AI timeline, so for example, this Sheki robot, which I talked about, it was mainly related to the knowledge representation and reasoning and robotic planning. Then I talked about Sorry?
Someone's
mic is not mute. Okay. Then I talked about the Deep Blue computer, which plays the chess. So that was mainly related to game search and AI search. So, but I'm not going to cover these topics, which are not part of this session. And I would definitely like to conduct further sessions if people are interested. But today we are going to mainly focus on these four terms. One is AI, obviously, ML, machine learning, deep learning, and data science. Okay. So let's move forward. Now let's talk about machine learning. So I think many people might have heard this term. So let's go and see why the machine learning is important and what exactly is machine learning. So first of all, let's ask why machine learning now? Why people are talking about this particular term nowadays? So there are three reasons for this. So first is the big data. So I think you all are aware that I think people have started using mobiles and computers and like watches and everything. Like there are hundreds and thousands of digital devices around in the world. So they are generating lots of amount of data, and that is called big data. So that tremendous amount of data which is getting generated from everywhere. So and that gives us very good opportunity to use this data and come up with something new and use this data in a very useful manner. Second is the computation power. So definitely we all are aware that before 10 years was a computer. It's now in our hand. It's a mobile. The same processing power is in our mobile. So the computation power has also increased drastically. And finally, there are a lot of algorithmic processes which has been invented in the recent years, which has given the boost to machine learning techniques. So I think there are these three reasons because of which nowadays this machine learning term is being used, and even the machine learning is being used in the real world scenarios. So machine learning, if we see in the like structure wise, it has been divided into three parts. First is supervised learning, second is unsupervised learning, and third is the reinforcement learning. So supervised learning, if you see, it's very simple. If you think it as some input to output mapping, we'll see in the detail about supervised learning. It's simple. For example, if you are given some input X and then you are mapping to some input Y or maybe A to B. It's like that simple. We'll talk more about supervised learning. Unsupervised learning is something like if you see, like it will be something related to not monitored specifically. So for example, if you have some data and you want to cluster the data in some particular group, you don't know what the data means, but you know that there is some kind of grouping between this data. So there unsupervised learning is used. And finally, there is something called reinforcement learning, which works on the feedback loop. For example, say you might have all played the Mario game. So if there is a Mario agent and you are playing a Mario, first time you are, say you are out due to maybe you fall into the pit or something like that. But next time, because you learn from that, okay, if you fall in the pit, then you are losing the game. So next time you will not try to make that mistake again. So basically, it tries to from the previous wins or losses. So losses. So I think that is kind of feedback loop which runs, and based on that, the machine learns how to play Mario game. So today we are not going to focus much about unsupervised learning and reinforcement learning. We'll try to cover supervised learning. And I think this is one of the most prevalent machine learning technique which is in the market. So I think that is sufficient to basically get started with the machine learning. So we'll mainly focus on supervised learning. Okay. So now, machine learning applications. So I think many of you might have used the machine learning applications, but may not be aware of it. But let's see. So for example, I was talking about the input A to B mapping. So this is the input A, and this is output B. So this is nothing but A to B mapping, and I have listed the applications here. For example, you receive an email. So your email server will basically categorize whether the email is a spam email or not. So it's very simple. So whenever you get an email, the system will see whether it is a spam email or not. So it's a 0, 1. 0 means it's not a spam. 1 means it's a spam. So this application is called spam filtering, and all the email applications you use like Gmail or Yahoo or Microsoft, anything, they use spam filtering to filter out this bad emails. The second application will be like, for example, you have some audio and now you want to convert it to the text transcript. For example, you give the our sessions audio and it will convert it into the text. This is nothing but a speech recognition. And speech recognition is also used in your virtual assistant. For example, whenever you speak something, your Google Assistant understands that whatever you are speaking. So that is nothing but speech recognition. The third application is, for example, you have English text and now you want to convert into a Hindi text. So A to B mapping. So A to B mapping, you have English and you want to convert it into Hindi. So this is nothing but a machine translation. So you are translating one language to another language using machine techniques or machine learning techniques, which is nothing but machine translation. Then the next application is, for example, you have some advertisement and you have user info, for example, my info and some advertisement. Now the computer system will predict whether I will be clicking on that ad or not, basically. So for example, recently I have been searching for the laptops. Then there is a high probability that I'll click on some advertisement which is related to laptop. So machine will try to predict whether if machine will show some particular ad, whether I will click on that ad or not. So that is nothing but used in the online advertisement. Say on Google, you see many times there are a lot of ads, and Google also try to see whether you will be able to you will be clicking on that ad or not, and based on that, it will show you the most relevant ads. So that is nothing but used in the online advertising. The next application is, for example, you have some photograph in front of your car and some radar information in front of your from your car radar system. Then you will be able to tell the position of other cars. For example, you are driving on a road, you click one picture, and you also have some radar information nearby your car. Then you can tell that what is the position of other cars. Then this application will be a self-driving car. So by telling you about all these applications, I want to make one point very clear, that if you think about machine learning, supervised learning technique, then there should be only one thing that should come into your mind, which is nothing but A to B map. Right? So it's like you are giving some input and you want to convert into some other input. That's simple. Okay. So final application, for example, image of a cup. Cup means our normal cup in which we drink tea or milk. So if you give the image, software or the computer will predict whether there is a defect in the cup or not, whether cup is broken or not, 0 or 1. So this is nothing but a visual inspection software. So I think the application should be very clear to you guys. It's very simple, A to B mapping. That's it. Don't remember anything else. Just see A to B mapping. So whenever you see any machine learning application, then try to basically map that into input and output. What is exactly the input? What is exactly the output? Okay. Folks, how is going? Are you able to follow up? People join online. If you can give some feedback. Okay, then I'll take that as yes, and I'll move forward. Okay. So now let's see further, like go into the more details of machine learning and how exactly it works. So I have taken two examples here. So it's a very simple examples. For example, first example is related to housing. Say you have been given, say, size of the house in square feet. For example, if it's a 1100 square feet flat, the second parameter or the input is the number of bedrooms. Say it has 2 bedrooms. The number of bathrooms. Say it has 2 bathrooms, and whether it's a newly renovated flat or not. So if it's a no, that means it's not a newly renovated. Y means it's a newly renovated flat. So no. So, and finally, based on this input, there is a price related to the particular input. Okay. So, so if you see this particular line, then 1100 square feet flat with 2 bedrooms, 2 bathrooms, and it's not newly renovated. Its price is around 40 lakhs. That means it's selling for 40 lakhs in the market. Similarly, you can take any other example, 2000 square feet flat, 3 bedroom, 3 bathroom, and not newly renovated. It's selling around 1.1 crore. Okay, it's very simple. So now you can think of this as this is the input A for you, and this is the input B. Output B. So now, say we want to create a software or create a machine learning application which will take the input A, this input A, and it will give the output B. So basically, if I give, so for example, this last line, say if I give 3000 square feet, 4 bedrooms, 4 bathrooms, and it's newly renovated, then it should give me the price of the flat. Like what should be the approximate price of this particular flat in the market. So this is nothing but a very simple machine learning application. Given this input, it should give the output. Okay. Now, so this data will be used by the application to basically learn things. For example, you can see the square foot of house to price. So maybe it will create a graph kind of thing, say a very simple straight line where here it will be size. Okay, and here it will be price. Okay, so whenever the size is low, the price will be obviously low. And the size of the flat increases, the price of the flat will also increase. Okay, so this will be kind of mathematical equation behind how it will predict the price. So to learn this, to draw this particular line, it might use some data, right? It cannot draw a line without data. So what it will do is it will try to use this data, this above data here, as the training data. Training means it will try to use this data and create some software. For example, this is our software. So this S is our software. Okay. Now let me just clear some of the things so that it's better. Now, once it has generated the software, what we'll do is we'll give this last line as the input. This is our input here, which is A, which will give this last line to input. And what this software will try to do is it will try to predict what is the price. For example, it will say maybe 2 crore. Okay. So this is very simple price prediction machine learning technique. So I think if you guys were able to follow. So this data, the above data, which is in white, all these rows, they are called the training data because we are using this data to train our model here. So train our software here. And finally, this is called actual data where we want to use this data to predict something. Okay, so this is called actual data. And finally, so we have another kind of data. Say, for example, we want to create a software which will predict whether given a picture, for example, this is one of the pictures, whether given a picture, whether it's a cat or not. For example, first picture is cat, so it is marked as cat. Second is car, so it is not a cat. Cat, then it's a cat. Cycle, it's not a cat. So in future, so based on this data, what we will try to do is we'll try to create a software, say S. In future, we'll give one new image, for example, an image of a computer or a laptop. Then it will try to predict whether the given image is a cat or not. That simple. So this is nothing but you can say it as maybe a image processing machine learning application. So it's processing one image and try to see what is that image related to. Okay. I think you guys might have been able to follow. So I'm moving forward. So please stop me if you have any doubts. Okay. So now what we'll do is we'll use this data, the data related to house, and we'll use this for understanding what is the difference between machine learning and data science. Okay. So machine learning, we have already seen that it's a given A, it will give us the B. That means it's a very simple A to B mapping. So I'm repeating this word A to B mapping so that it's stuck in your brain, and you are very much aware that machine learning applications are always A to B mapping. It's very simple. So, and to get into the formal definition, you can say that machine learning is a field of study that gives computer the ability to learn without being explicitly programmed. So, for example, you gave this data, and without telling the actual price of this particular last row, it gave you the price. Maybe it's not a correct price, but it will try to give you the price, maybe 2 crore, and maybe the actual price is 2.2 crore. It might be correct, it might not be correct, but it's trying to learn out of what you are giving to the computer and trying to predict basically trying to predict the unknown data. So that is machine learning. That's very simple, A to B mapping. The second is the data science. Okay, so data science is mainly related to knowledge extraction in the insights extraction. For example, data science for this particular table or the data means, for example, one of the insights can be house with the 3 bedrooms are more expensive than the house with the 2 bedrooms of the similar size. So, for example, if you see here, house with the 1400 square feet with the 2 BHK and house with the 1500 square feet, it's almost similar size, but it's a 3 bedroom flat. So you see the difference between the price is very high. So this is one of the insights which will come out of the data science application. For example, there will be some application or some software which will give you this information. Okay, given this data set, it will tell you that, okay, if you have a 3 bedroom flat, which is almost similar size to the 2 bedroom flat, then you might be able to get the higher price in the market. So it's selling for more price. So that is one of the insights which will come out of the data science application. And the second insights, you can say that maybe the newly renovated homes have a 15% higher price. For example, here you can see why means it's newly renovated houses. So it has some extra premium. That means if it's not newly renovated, then it's selling for some lower price. But if you renovate the house, then it will sell for a higher price. So this is very simple term, data science. So data science is nothing but you can say that it's the science of extracting useful information from the data. Very simple. So I will repeat once again. So machine learning is nothing but what A to B mapping, and data science is nothing but extracting the knowledge or useful information out of the data. We'll see what is the relation between these two terms in the future slides. Okay. So let's move forward. So now I will talk about the one of the other term in the market, which is called deep learning. So first of all, deep learning is nothing but a tool of machine learning. So it's not a, for example, like machine learning or data science, it's not a different thing as such. It's just a, you can see algorithm or the technique inside the machine learning. Okay. So we'll see one of the example. It is called demand prediction. So in deep learning, nowadays there is like one of the most famous technique, which is in the market, which is called neural network. So let's see. It's very simple. I'll try to explain in very simple terms. Okay. For example, the similar data set that we use in the previous slide, right? So previous slide we use size of the house, number of bedroom, number of bathroom is newly renovated. Okay. So we'll use the same data here. I'm just labeling the data, not showing the actual data here. So for example, size of the house, number of bedroom, number of bathroom, newly renovated. This is our input A. Okay. Now, what can you tell from the size of the house and number of bedroom? So you can tell that, okay, this is one of the biggest factor in deciding the price or the demand of a house, right? Because it's a size. It is called size factor. We can call it size factor because the more or the larger the house, the more number of bedrooms are there. Then definitely it's like many people prefer the larger houses. Okay, so this is a size factor. Now there can be another factor, which is, say for example, from the bedroom and the bathroom, you can say that it's a comfort factor, right? Because more the number of bedrooms and bathrooms are there in the house, it's comfortable for people living in the house. So let's call this as a comfort factor. So now there is a relationship between this, right? So for example, size of the house and the bedroom, they both combine into a size factor. So assume that here there is a mathematical equation. For example, X is the size of the house into Y is the size number of bedroom is equal to say something C. So this C is nothing but this black dot. Okay. So means it's some relationship between these two factors, like size of the house and the number of bedroom, which comes to a size factor. Similarly, if you have a number of bedrooms and number of bathrooms, then some mathematical formula will come into picture and it will say what is the comfort factor for this house. Okay. And finally, if it's a newly renovated, then obviously it's a condition factor that, okay, house condition is good or bad. So that will also impact the demand or the price of the house. Right? So these are the three main factors which we are considering. Okay. So let me just clear this out so that we can see the next thing. So till now we have taken the input. This is all input, and we have computed these factors. So these are all the factors which we have computed. Now what we can do is, based on this factor, we can combine all this factor and finally we can decide what is the demand of the house. Obviously it will depend on all these three factors. So this is nothing but a stage related computation. For example, in the stage 1, so if we call this as a stage 1 and this is a stage 2, then what we are doing is, in the stage 1 and 2, we are trying to compute something and finally we are giving something as the output, which is nothing but our output B. So again, I'm repeating, we are giving input A and we are receiving the output B, A to B mapping, and it is not, input is the house data and output is the what is the demand of the house. Okay, that's simple. So this particular stages which you see, this is called a neural network. Okay, and neural network is like deep learning might have many techniques, but the most famous technique is the neural network. It's like, you can say that deep learning is almost equivalent to neural network nowadays. Okay, so this is nothing but a neural network. the neural network, so here you see we have only two stages. So stage 1 and stage 2. Now in the different kind of application, say this is our input A. For example, the image which say for example you uploaded an image on the Facebook. So Facebook uses these neural networks to basically recognize who is in that image. So they will have a large neural network. So here we had only two stages, stage 1 and stage 2, but they might have like millions of stages or thousands of stages. Okay, so it will be it's called large neural network. It will be a large neural network, and it will give output B. Again, the concept will remain the same: input A, output B. But when the internal computation will be done in thousands of stages, and one of the most like benefit of this neural network is humans as a human, we don't need to know what is exactly happening inside all these stages. The computers themselves learn what is exactly what and what. So for example, here we manually decided that okay, the stage number one is size factor, comfort factor, and the condition factor. And then we said that okay, combining these three will give us a demand or the demand factor. But in the real world, you don't need to tell any of this to computer. Computer will learn automatically, which is nothing but a machine learning. You can relate that terms, right? Machine is learning itself that okay, what are the most important factor in this data, and based on that, it will decide the output. So, for example, in the Facebook's context, whenever you give an image, machine will automatically try to figure out whenever, say, for example, my image, Nirav's image is coming, then how the computer can learn that this is Nirav's image. That will be this neural network. And in future, whenever I upload any new image, it will use this neural network and basically detect whether means I am in that image or not. So that is like a core concept of deep learning. So I have tried to explain it in a very simple terms, but obviously real world applications can be much more complex, and there can be a lot of things which go around. But in general, you can always relate that machine learning is always input A to output B. In between, there can be many different techniques, or maybe neural networks or something else we will be using. Okay. So now let's move forward. So what we have done is we have tried to see all the terms like AI, machine learning, data science, deep learning. So we try to see what are these terms and some technicality inside those terms. Okay. So let's move forward. Finally, just want to talk about the performance of the machine learning and why nowadays the machine learning is so famous. So machine learning is also around in the world since 1970s or 60s, but they were all traditional machine learning models which were mainly dependent on some mathematical or statistical technique. So the problem with this data, this techniques was, say this x-axis you see, this is amount of data. So even say for example, this is 2019. In the 2019, we have drastic amount of data compared to say 1980s. So okay. So but the problem with this traditional machine learning techniques are that even from 1980s since till 2019, the amount of data has increased drastically or exponentially. But the problem with these techniques are that the performance is not increasing that much. Like you can see, like it's almost flat. It's not going up with the data. So generally people believe that okay, more data means you can get better results, but that is not very true with the traditional machine learning techniques. So we have seen this neural network, right? Deep learning and neural network. So so the benefit of neural network was that the more and more data which we can feed to the neural networks, they can learn more. For example, if you are a small size neural network, say for example, small size means say 100 stages, then definitely it can, with the more amount of data, it can give you better results. You can see from this graph. Okay, so I'll just clear my marking so that you can see the graph clearly. So this is small network, and say for example, you have a medial neural network with 1,000 stages, then definitely it's increasing in the performance with the amount of data. And finally, the large neural network. So if you are say tens of thousands of millions of stages, say 1 lakh stages in the neural network, then the performance keeps increasing. You get better and better performance. So that's why nowadays this large neural network, they are called deep learning, which we saw in the previous slide. So I just gave you the example of two-stage neural network, but if you imagine that there are lakhs of stages in that particular neural network, which is nothing but a large neural network, then it's a deep learning technique, and which is the most famous techniques are there in the market right now. And so if you are very curious about deep learning and you work with some of the biggest companies, then definitely you will get chance to work on deep learning techniques. And why the large neural networks are getting famous is because, again, we talked about those three things, right? Because the computation power is increasing, we are getting more and more data, 2019, okay? And and techniques are also improving, the neural nets and everything is improving. So because of all these reasons, nowadays, recently the neural network or the deep learning is one of the biggest buzzword in the computer science, and they are being used everywhere, almost everywhere in the computer, large machine learning applications. Okay. So moving forward. So now what we have covered is we covered a lot of these terminologies, right? So we started with the term artificial intelligence, right? Sorry. So we started with the term artificial intelligence, and then we saw some of the history in which we saw the knowledge representation, robotic planning application, gaming application with the IBM's Deep Blue computer, AI in search technique, again with the Deep Blue computer. And then we shifted our focus to the machine learning. We saw what is machine learning, which is nothing but A to B mapping. Then we saw some very simple example of extracting the knowledge out of the data, which is nothing but a data science technique. And then we saw the deep learning, right? The large neural network, which can help you analyze the large data and give the best performance compared to the traditional machine learning techniques. So now let's see what is the relationship between all these terms. Okay. So now,
sir, data science, you told us that it's extracting insights from a lot of data.
Correct.
So, sir, what is exactly the difference between data science and data analytics?
I think I'm really not I have not gone into the exact difference, but I would say it will be very similar sounding words, and I think the applications will be similar. So to be frank, because this I have like to compare these words also, like I have done some analysis, so I have not done analysis for analytics, data analytics, but I think the main terms are these. But if you see data analytics, it will be one of the techniques inside data science or something. Frankly, I'm not aware. Means I am aware of the term, but I'm not aware where exactly it lies. Okay.
Okay, sir. Thank you.
Yes. No problem. So if you see, so artificial intelligence is one of the like major umbrella, which you can say, where we discuss, right, that what machine learning, so the normal machines doing the task which humans do, okay, the specific task or some general task. So it is a very big term, and the machine learning will be one of the sub-terms or the subset of artificial intelligence. And as I already stated that deep learning is nothing but a tool in the machine learning. So deep learning is coming inside the machine learning umbrella. And data science is mainly an intersection between these terms, because in data science there are something called, say for example, data processing. How you process your data, pre-process your data. Say for example, your data is not structured enough. For example, it's not in a table format, it's in some very different format. Then how do you process the data, or maybe how do you store the data? So there are different things which comes into data science which are not in the purview of intelligence as such. So they are not very intelligence specific tasks. So they will be like not in the purview of this artificial intelligence. So I think this chart I have tried to summarize what like generally what does these terms means and how they lie. And I think it should give you a clear idea. So whenever say you see any applications, so you try to map this, that okay, this is inside the artificial intelligence and machine learning technique is being used, and deep learning is nothing but a machine learning like sub technique, and data science is nothing but getting a useful information out of the data. Okay. And there will be definitely, for example, one of the folk, I don't see the name, but he asked that what is data analytics. So frankly, I am also not aware what means, how exactly you can draw. For example, it may be here, or maybe inside data science, or maybe cutting this across. So I am also not aware how exactly it will lie, but you also can go ahead and try to see by yourself that okay, what is exactly data analytics, or there are other few terms also where exactly they lie. But but generally in the industry nowadays, these are the terms which are mostly used, and yeah, so I try to cover those terms. And so finally, some of the challenges. So we now covered very basics about AI, machine learning, deep learning, data science, and everything. And now, what are the challenges in this techniques? So one of the challenges is provability. So that means, for example, if you are using a neural network, large neural network, say you are giving input A and output B. So it's very difficult to prove how machine is extracting the information. For example, you have given a cat photo, say cat photo, and your machine is trying to extract particular image, cat out of the image. For example, image processing, very simple application. But the problem with the techniques are that they will tell you whether it's a cat or not, yes or no, but they won't be able to tell you how they are able to come up with these decisions. So there are certain provability challenges in the AI techniques. So nowadays, if you are interested in the research, there is a lot of research going into the provability things. For example, given an input A, it will give output B plus some reasoning. For example, why your machine learning is telling that this is a cat. Okay. So sometimes it might happen that okay, there is a photo of cat and there is a grass here. Okay. So whenever you try to train your machine learning neural network, what happened was you gave all the files or all the images which had some grass in it. So what happened was your machine learning algorithm or the application neural network, it learned that whenever there is a grass in the picture, it will tell that it's a cat, and if there is no grass, then it's a no. So even though you are able to detect cat in the picture, so basically whether a picture is related to cat or not, but actually your machine has learned something other than what you expected it to learn. For example, you expected that machine should learn that okay, if there is a cat, then it should tell yes, otherwise it should tell no. But machine has learned that If there is a grass, then I will tell yes. If there is no grass, then I will tell no. So sometimes it's difficult to use this kind of application. So now people are coming up with applications where they will say something with some reasoning. For example, whenever you give the new picture, it will say that, okay, in this picture there is a one cat. I'm say 80% of the confidence I am saying this is the cat, and this picture relates to cat, or maybe 20% with some say grass or something. 20% confidence, it's a grass, and 80% confidence there is a cat. So those kind of probability research is going on in the machine learning research nowadays. So that is one of the challenge. Second challenge is data privacy and security. So for example, we all are using Facebook, WhatsApp, Amazon or Google and everything. Like we are constantly 24/7 online, and we generate a lot of data on daily basis. Now, you might have heard about a lot of incidents happening with the Facebook, where Facebook has given our data to some other company which are using for some other purpose. For example, to figure out our political views. So, and there are a lot of things happening around this data privacy and security, that how the company should handle the data and who should access the data. So I think there is a huge challenge here. So where data privacy and security is like becoming one of the major things nowadays, and almost all the companies are focusing on making the data more private, more secure, more user specific, and even the governments are also forming a lot of laws around this. So yeah, so data science, data privacy and security is also one of the challenges. And algorithmic bias. Some of the algorithms are biased. For example, we talked about this neural net, which was predicting the grass, based on grass, it was predicting whether it's a cat or not. And another example would be, for example, you have 1,000 files. All the files are related to black cats. There is not a single white cat in your training data. So what will happen is, in future, whenever you give a white cat photo, it will not be able to predict. It will say there is no cat in the picture, because it's not because the algorithm was feeded the data of all the black cats. Now algorithm doesn't know that okay, there is a white cat in the world. So and the computers are not that intelligent enough to figure out that okay, if there is a cat looking picture and it has different color, then it's a cat. So that kind of intelligence is not there. So that is also one of the big concern, where whenever you train your data or application, it should be with proper data and like diverse data. Say for example, if there are 5 colors of cat in the world, then your algorithm should be trained with all 5 colors. Otherwise, in the future, when you give a new color cat photo, then it won't be able to predict. Okay. And finally, the data scarcity. So nowadays, this is basically going down. So previously, when there was a less amount of data, people were not able to, say for example, create huge neural networks or huge like models, which basically runs on large data, because model basically machine learning application, they need a good amount of data to give good results. But previously there was not a lot of data, but I think nowadays the data scarcity is becoming very less and less. That's it about the challenges in the AI, and I think now I will conclude. We started with the big opportunities. So I think I think all of you are in colleges, right? So whenever you are targeting your placements or anything, so I think there is a huge amount of opportunity. If you are expert in this field, then definitely there are thousands of opportunity, I would say. People are actually looking for machine learning, data science, and AI experts. And there are huge openings, and there is a scarcity of experts in this field. So definitely, if you are looking for a great career in computer science, then I think one of the field you can choose is the machine learning, data science, and the AI. Okay, so we talked about the opportunities, and we talked about the inevitable thing. For example, AI will definitely take over almost all the fields by 2030. That's the prediction by many of the people in the world. And then we obviously went into the technical details of what AI, ML, DS, and everything, right? The neural networks and everything. And finally, we talked about what are the new challenges which are to be solved in the particular techniques. And yeah, that's it. So I'm concluding this session, and definitely I'll try to take the questions if you guys have any. And so this, maybe I am not sure how the PPT is shared, but we'll share the PPT if possible, or maybe you can contact me on my personal email ID, and you can also connect with me on the LinkedIn. So, folks, any question or anything you want to share here?
Awesome, Nirav. So I think we'll share the PPT with everybody. And folks, if you have any questions now or later, feel free to share with Nirav. He is very passionate about teaching and sharing knowledge. So he'll definitely love to answer all our questions.
Yeah, definitely. Please reach out to me.
Yeah. So we'll share your email with everybody, Nirav.
Sure, Pramit. Thanks. So Pramit, yeah, that's it from my side. We can conclude actually if there are no questions.
Awesome. So anybody, any questions for Nirav? I think it's good. We'll give all the material to the students. So let them follow up, revise, and they can come back with questions at their leisure.
Definitely.
Yeah, and we would love to hear more from Nirav with maybe some deep dive into one or specific part of it.
Definitely.
Hello.
Yeah, Amol, please.
Sir, can you please tell me where to start it all from? Because previously I attempted to learn machine learning और मतलब मेरा छूट गया बीच में, तो मतलब कहाँ से करें, क्या करें?
हाँ, तो जैसे कि मैंने इनिशियली एक आपको वो दिखाया, just a second. So Andrew Ng, if you have heard of Andrew Ng, so Andrew Ng is one of the so have you used Coursera?
Yes, sir.
हाँ, so Coursera आपने use किया है, तो he is the co-founder of Coursera and he has one of the best course on the machine learning actually. And if you want to get started, I would recommend you start with this particular course from which I have taken some of the content. You start with this course which is called AI for Everyone, and what I'll try to do is I'll share the another course which is called Machine Learning by Andrew Ng on this. And I would not recommend any other course. Like his course is like one of the most used in the world, right? It's like the best course of machine learning. So I think you can start with the AI for Everyone. It's a very small course actually. You can start with this. This will give you a very nice basic and abstract understanding of what are the techniques available in the market and what is the scope. And finally, if you are interested, then you can go into the specific course. For example, he has the courses on machine learning, deep learning, and like there are a lot of other courses related to this. So I think this course will be a very great start for you to get started. And then I would recommend the machine learning course from Andrew.
Okay. Thank you.
Yeah. So I think Pramit, we can conclude then.
Yeah, man. I am also going to take that course, by the way.
Yeah, I think it's very helpful. Yeah.
Awesome. So yeah, thanks for finishing early ahead of time. I think
Okay.
yeah, we can call it a meet. If students have any questions, we'll have a mail thread where they can ask.
Sure, definitely. Yeah. Okay, thank you folks for joining and for participation.